Right, okay, let's look at this question. This is the second video for the area between two curves. So in this case here, I have to sketch the graph y and x axis. So I have the graph of y equals to x squared minus 2, right, negative 2. So where's the graph will be moving this way? It's between the quadratic curve and this line, right? So y equals to negative x, you know that it will be passing through this way. So this is the region bounded, right? So for these cases here, the region bounded is from this point, from point A to point B. Where this point A and point B, we are not given any point A and point B. We have to find these 2 points by doing simultaneous equation between these two, right? So as this is the graph for y equals to x squared minus 2, and this is the graph for y equals to negative x. So these two graphs intersect at these 2 points, means that the value of y will be the same because they are sharing the same point, right, during intersection. So then we can say that x squared minus 2 equals to negative x. So we're solving that quadratic equation. So we were getting x, 1 and 2, positive and negative, right? So we're getting two value of x, which is 1, and the other one will be negative 2, right? So means that negative 2 will be on this side, okay? It will be on this side. Point A is a negative 2, means that the value of x here is negative 2 up to 1, all right? Up to 1. So now we know that they are bounded by these two graph is bounded from x equals to negative 2, means that the graph is enclosed, is closed from negative 2 up to 1. So now I'm going to find the area of this region, right, by applying the concept of area. So from negative 2 up to 1, right, it's from negative 2 up to 1 where the region is enclosed. So in this region, the line is higher compared to the quadratic curve. So the line, which is negative x, have to take away the curve x squared minus 2 dx, right? So now then you just integrate and finding the area, negative 2 up to 1, and you will have negative x to the power of 2, negative x to the power of 2, plus with 2 dx. But this is the most important one, that you're getting your idea here from the graph. So as you integrate, you're getting negative x2 over 2, negative x cubed over 3, plus with 2x from negative 2 up to 1. So then you have to evaluate this by putting the value 1 squared over 2, negative 1 over 3, right? Plus with 2 times with 1, take away negative 2 squared over 2, negative 2 to the power of 3 over 3, plus with 2, negative 2. So then you have to evaluate. Alright, so for this you are getting 7 over 6, right? 7 over 6 minus with this negative 2, we have negative 10 over 3. So let's sum up these two. 7 over 6 add up with 10 over 3. So we get 9 over 2 units square, right? 9 over 2 units square. Alright, okay. So you have seen that how I did, what's the strategy that I'm doing. So first I'm finding the region, identify the region. If there is a need for solving simultaneous equation to finding the value of x, means that where's the graph bounded from which x value to the other point, where the two intersection point here. So thirdly, with using this intersection point to integrate, right, then we're taking the line here minus the curve, as the curve is lower. So then we can evaluate just by this way. So let's move on to the second examples. Alright, okay, the second example of this video. So find the area of the region bounded by the curve here. So we have 3 curves here. So there are more than 1 curve, even though it's between 2 curves. So I want to talking about, okay, let's see. We're sketching this curve first, then we can see where is the graph that bounded between 2 curves and not bounded by 2 curves. So for example, I have to be very familiar with all these graphs here. Okay, I have to be very familiar with all these graphs here. So where I have x plus 6, right? The straight line x plus 6. So x plus 6 is in this region. So you have negative 6 as your x-intercept, right? If you find the x-intercept and y-intercept here, you are getting a graph to be this way. All right, okay. I just put it negative 6 here. So negative 6. So this is a straight line for y equals to x plus 6. And the line y equals to negative x over 2, right? Y equals to negative x over 2. So is looking at this way, right? This is the graph of y equals to negative x over 2. And also the graph of y equals to x cubed, right? X cubed. So the graph for x cubed will be going this way, right? So this is the graph for x cubed. So as you know that the graph for straight line, you are very familiar with, and you know that this is a simple cubic function, so which will be looking at this way, right? So where is the region bounded by these 3 graphs? These 3 graphs together is bounded where? It's not here, right? This is unbounded. So this is the region where the 3 graphs, this is the region where it's bounded by the 3 graph here. So then you have to look at this region. You have to evaluate this region. So you have to be careful with this, as you need to see that there are 2 different regions here. One is between the line, and the other one is between the line and the cubic function, right? Between the line and the cubic function. So how to finding this region here? We have to finding this point and this point here, because it's from this negative value of x here to the positive value here, right? So we have to solve simultaneous equation between these 2, right? Between this line and this line. So at first, to find this point, it's between this line and this line, right? It's not related to the curve yet. So it's between this line and this line. So we consider between this y equals to x, negative x over 2, and the line y equals to x plus 6. So we equate the y. So we have negative x over 2 to be x plus 6. And we're getting negative x equals to multiply both sides by 2. Right? Multiply both sides by 2. So we have negative 3x equals to 12. And we're getting x to be negative 4, only one value. Right? So means we know that this value here, okay, just putting the negative 6 to be, the negative 6 is here. So, but this more important value here is negative 4 here, right? The negative 4 is from negative 4. So, so now for this, we have to solve simultaneous equation between the curve and the line, right? All right. So now we're going to find the intersection between the curve and the line. So it's all involving between this line, y equals to x plus 6, and the graph of y equals to x cubed, right? It's between this line and this curve here. So to finding this point, we have to equate the y. We know that during the intersect, the x value will be the same. So we have to solve some cubic equation by using the knowledge of polynomial, right? By using the knowledge of polynomial. So as we know that we can try the value, as you can try the factor of 1, 2, and 3, and 6, right? A factor of 6, and we try the value here. So if we're putting the value of 2, right, we were getting 0 here. If you see that, if you're putting the value, let's say you assume this to be your fx, x cubed minus x minus 6. So as you substitute the value of 2, right, you substitute the value of 2, you are getting 8 minus 2 minus 6, which gives you 0. So the 0 here tell you that x cubed minus x minus 6 having a factor of x minus 2, as 2 making this to be 0, right? From your knowledge for polynomial. So okay, from here I can factorize this easily by putting here as another quadratic, x squared plus bx, ax squared plus bx plus c. So I can find the value of a, as value of a will be 1, right? Because ax squared multiply x, you have ax cubed, which is 1 here. So, and for c, you know that negative, the constant term here, negative 2 multiply c, you are getting negative 6, right? Negative 2 multiply, negative 2c, sorry, negative 2 multiply c, you are getting negative 2c equals to negative 6, you're getting c equals to 3, alright? So finally, you know that x cubed minus x minus 6, you are getting x minus 2. Your a is x squared plus bx plus 3, right? Plus 3. So finally, you have to find b, right? This factorizing, so you want to find b, you may be choosing the coefficient for x, which is negative 1. So what's the coefficient for x here? So you will have x cubed, x squared, positive 3, right? Negative 2 is not related. Okay, negative 2b, right? So you have negative 2 multiplied with b, negative 2bx, which is the coefficient for x also. So then finally we got negative 4 equals to negative 2b, and we have b equals to 2, right? So finally I factorize this to be 2. So, and I solving this equation. I have to solving this equation because I have to solve this equation. So after I factorizing, I take this equals to 0, right? I take this equals to 0. So as you see that this one is imaginary roots, right? You can see from the graph here, the curve for y equals to x cubed is intersect the line at only one point, right? Only one point. Means that if you're using calculator, in calculated this, or you're using discriminant, you were getting b squared minus 4ac less than 0, which there are no real roots come from here. So this one will not be 0, and only x minus 2 will be equals to 0, which is x equals to 2. So then I know that this will be 2, right? I know the intersection point between the graph y equals to x cubed and this straight line will be intersecting at the value of x equals to 2. Alright, after I solving all these things, I get all the intersection point between this in this region, then I can start integrating. Alright, okay. Now we have to see that this region, this is must be careful here. This region is divided to two parts. One is the region A and region B here. Do you know why? Because this A is bounded between the line and the line, right? And for this region is bounded between the line and the curve. So we have to separate it into two regions here. So okay, as my advice here, you have to calculate area A and area B separately. Alright, so I taking the area of some students were looking at this way. They were taking the trapezium here, the trapezium minus away this triangle and this region here, right? So okay, I think you can do it this way because why? Because this is easier to calculate, right? It's easier to calculate here. So okay, let's try the one that I said, the trapezium minus away the triangle and the area under the curve here. So my meaning here is I'm taking this region, alright, this region below the curve here, everything, can you see there is a trapezium here, right? Minus away a triangle here, right? Minus away this part here, and minus away the curve here, right? Minus these two regions here. So okay, let's try by using this. So means that the area, I can write out everything. So the formula for trapezium, right? trapezium, half A plus BH, right? A plus BH. So this is your A, this is your B, two parallel sides here, right? So the height here, -4. You can find the value of height here by finding the y value here, -4, right? -4 substitute into this line, so you have -4/2. So you're getting 2. Means that the value of y here is 2, so means that the height here is 2, right? The value of A here is 2. And finding the value of B is to substitute 2 into this equation, right? This one, or you substitute to the cubic, you are getting the same value. You're putting 2 here, you're getting 8. You're putting 2 here, you're also getting 8. So it means that the length here will be 8, right? 2 plus 8. Multiply with the height here, right? The h, this is your A, this is your B. So the h here will be 2 minus -4. The length is 2 plus 4, right? 2 plus 4. So we have 6, right? 2 plus 4, we have 6. So, alright. So we have 2 plus 4, we have 6. And take away, minus away the area of the triangle. The area of this triangle. The area of this triangle. So which will be, okay, the triangle. Okay, let's see. From here, you have 4, -4 means that the size for this length here is 4, and the height here, just now you calculated, is 2, right? So we have to multiply with the height and the base length, 4. And minus away the area of this curve. The area under the curve here means that you have to minus away the area under the curve here, which is the curve of y equals to x cubed. So for this section, I have to integrate because it's a curve. So integrate from 0 up to 2, 0 up to 2, x cubed dx. This will be a complete, alright? Complete. So after you minus all this, you are getting the area for this region here. So as I calculate this, you have 2, 3, 6, 8 plus 2, 10, right? 10 times 3, you have 30. Minus away 4, minus away, okay, let's integrate this. You have x to the power of 4 over 4 from 0 up to 2. So I think this will be easier, right? So easier, so minus with 2 power 4. 2 power 4 is 16 over 4, right? So which will be 30 minus 4 minus 4. So which give you 22 unit square, right? So we are actually looking for an easier strategy in finding the area bounded between the graph. All right, hope you understand, and I will give more example in the next video.